Hey guys, this is Tom Cunith. I'm a Senior Solutions Architect in Cisco's Advanced Services. In this video, we're going to talk about WAN Edge Bring Up, sometimes referred to as onboarding. So with me today, I have Sarah, who's a Systems Test Engineer.
How you doing?
Doing great, Sarah. How are you?
Doing well.
And also Zane, who's a Technical Marketing Engineer.
Hi, Tom. How you doing?
Doing excellent, Zane. You ready for this session?
Absolutely.
All right, so Siraj is our lead presenter today, and he's going to walk us through the complete process of WAN Edge Bring Up. Siraj?
Thanks, Tom. Yeah. Let's look at the present architecture and see how ZTP helps us bring up the WAN vEdges in an overlay in an automated way. So ZTP resides outside the architecture as a cloud as a service.
And you said ZTP?
Yeah.
Which is a zero-touch provision.
Yeah, zero-touch provision. It resides in the cloud as a service, as a software, as a SaaS. And we want to automate this bring up of vEdge into the overlay in an automated way and also in a simpler way. So I'll walk through some of the steps involved in the ZTP process and how this vEdge joins the network overlay. So basically we have three kinds under ZTP. So basically the first one is the hardware vEdges and the Cisco version of the ZTP server, which is called as plug and play. And the other version is how we bring up the software vEdges and how do we provision and bring up in the overlay.
So the first two are essentially the same, right?
Yes.
And the concept is you just want to be able to take a new device, pull it out of the box,
Yes.
plug it in, and then have it connect it to a circuit and have it provision itself from the cloud.
Yes, exactly.
Okay.
Yeah. Let's see the scenes behind the ZTP. So as the first process, when the box gets shipped to the customer, so they basically have to just power on the device and connect one of the interfaces to the DHCP and mark it as a DHCP server. So you might be wondering what interface the customer would connect so that it will connect to the public circuit, right? So we have predefined interface lists. For vEdge 1 case, we have Gigi 00, and vEdge 2K series, we have Gigi 20, and vEdge 100B or 100 HEMS, we have Gigi 04. So we request the customers to plug in to those interfaces and connect to the internet. So basically what happens is there would be a software that gets shipped predefined in these vEdges. So what are some of the configs that the box would have is, it's basically one of these interfaces would be marked as DHCP client, and we would have under the system, say, ZTP server. What is the ZTP server you would reach to? ztp.viptela.com.
One quick question regarding ZTP. So that name must resolve, the DNS name must resolve to a public IP address, correct?
Yes. So you should basically have the DNS server pointed to 8.8 or any open server, which can resolve.
If you're doing DHCP, I would think that your ISP would provide you with a DNS server as well to work with, right? So,
yes.
Okay.
Another component is this can be considered a vBond of vBonds, correct?
Yes, correct. So
vBond is responsible for authentication, right?
The ZTP server would again point to what vBond you want to point your vEdges to. So I'll walk through those steps in the further slides. So the next step is, as I told you, we would ask our vEdge to resolve the ztp.viptela.com, and it would get results.
But that configuration is already out of the box when you turn it up.
Yes.
It's already going to be looking for ztp.viptela.com, right?
Yes, correct.
Got it.
So it would resolve ztp.viptela.com. It goes to the ZTP server and it gets verified. The vEdge, which is connecting to the ztp.viptela.com, gets verified So what gets verified here? So all our hardware vEdges get shipped with chassis number and serial number. So what is this chassis and serial number is the TPM chip that gets shipped with all hardware devices. So
basically the burned in certificate that's already been signed
by AVNet.
By AVNet, okay.
Yeah. So this is what is verified by the ZTP server. So our Cisco Cloud as a Service can push this serial list, which we call which is a combination, which is a tuple of chassis number and the serial number, onto the ZTP server in hand before, or you can also manually do it.
So if you wanted to bring up your own enterprise ZTP server instead of using the cloud,
yes,
you have that option.
Yes.
So again, to verify the ZTP, verify the vEdge, that's done by the AVNet certificate. That's built in, correct?
Yes.
Can you just talk a little bit about the difference between the verification that's happening now in ZTP and the verification that happens later in the overlay bring-up process with the vBond?
So it is basically verifying this uploaded chassis number and serial number. As of this part of this verification, it is just verifying is this chassis and serial tuple is already present in the ZTP server. That is the authentication process as of now. So once it gets verified, our ZTP server would point to the right vBond. So the main purpose of the ZTP is point to the right vBond.
Okay, so you've got this cloud-hosted ZTP server, and it's servicing multiple customers.
Yes.
You bring the chassis up.
Yeah.
It presents itself with its certificate and its chassis number. Mm-hmm. It's already been pre-provisioned and allocated to a particular customer, yes, and he knows who the vBond is, and then redirects him to that,
yes,
that vBond.
Yes.
What if the vBond is an on-prem deployment versus on the cloud?
So it has to be a publicly available server. So vBond is one of our orchestrator, and that is one of our main goals of the Viptela solution is have the vBond in somewhere in the cloud so that we can get past behind the NAT. It also acts as a stun server, which will be explained in the NAT section how we get past NAT with the help of vBond. So it has to be somewhere in the public. So now it has got which vBond to connect to, and now vEdge connects to the vBond and it gets verified. How it gets verified is again via the certificates and also the chassis and serial number, which got pushed via vManage onto the vBond. Or
that cement, is it the AVNet certificate at this point, or are we using a different one?
No, we are using the semantic. By default, it is the semantic one, but customer can use their own root CA. And
so there's two components of authentication, correct? One
yes,
is the certificate, and the second is the whitelist that's configured already on vManage.
Yes, correct. The whitelist is basically the chassis and the serial number, and the certificates part is the root CA thing.
When you say that the whitelist is configured on vManage, I think that vManage sometimes will push those configurations, but ultimately it's the ZTP server that's keeping the whitelist.
Sure. How would a customer get a list of chassis, for example?
You can also push that list on the vManage by yourself. Otherwise, we'll pre-map it via the cloud services onto the ZTP server, right in the inventory level. Right. So we would assign it to a particular organization. So now that our vEdge is verified by the vBond, so the next step is the vBond redirects to the vManage. So it tells the vEdge, go connect to this vManage, and it again gets verified here, all the certs part and the chassis and the serial number part, it gets verified on the vManage. And vManage then provides the system IP. Until here, the system IP is null. So system IP is how we recognize a device uniquely on an overlay. So once the vManage provides the system IP, whenever the config in the system knob is pushed, the control would flap, control connection. So whenever the control flaps, the first process is, again, you go to your authentication server, vBond, and he would again redirect to what your vManager is. Again, the verification happens. And here it receives the full configuration. How it receives the full configuration is the customer has to provide the templates on the vManage. So he also has to specify what the golden image he wants the device to come up with, and also the complete device configuration.
When you talk about the system IP, is that already pre-configured on vManage that the vEd will get?
Yes. As part of templates, we would already been pushed in the templates of what system IP this device has to come up with.
And so why is that a two-step process? Why wouldn't we just push the whole config at the step 8? Is there a reason for that?
Yes. We want to have a netconf session from the vManage to this vEd, right? Mm-hmm. So we would have a netconf session with the system IP.
So to do netconf, we need to have an IP to IP socket.
Until here, there is no system IP, right? And when you want to push in the config and all this golden image, you want a netconf session to the device.
And then you said in step 9, the connection will flap.
Yes.
Yes. That's by design that happens.
Yes. Always whenever you push any config under the system knob, it is like you are changing the device parameters, right? Yeah. So you would always want to authenticate it. So you always want the control would flap, and you will always redirect to the vBond, and vBond will again tell what the other controller.
So will vBond look back at the cert?
Yes.
And make sure everything is good?
Yes. Yes.
Okay.
Yes. At every step, the authentication happens here. So now the device has got its full configuration with the golden image. It goes for a reboot and comes up with the configuration what the user wanted. So now it again goes to the vBond, gets authenticated whenever the reboot has occurred. So your control has flapped. It goes to the vBond, connects to all of the controllers, and joins the network overlay. So this is how you bring up the WAN vEd without any zero touch, like with zero touch, no touch from the customer. So it is all automated from end to end, and this is all done as a part of staging facility. So what is a staging facility is you don't have actual routes being advertised between all of this. You only have the basic system configs that gets pushed. So you don't want the routes to come in and disturb the network since it is not already in the customer topo. So you want the basic config that the customer wants, and also the image what the customer wants to be pushed as a part of staging facility. Once the whole process is completed, you can move on the vManage from staging to valid.
So that's something an operator would do. As you're onboarding, you first leave, I think it was the certificate page, you leave it in a staging mode?
Yes, correct.
So that you can get your config, you can build your control connections, but you won't build any IPsec tunnels or BFD, it's non-disruptive to the network.
Yes, correct.
And then once you're satisfied that everything looks good, you do your checks, you can then move it from staging to valid. Valid, right? And then it builds the BFD and IPsec.
I want to go back to step 4 and 5 quickly. Mm-hmm. So step 4, again, the vEd gets verified by ZTP, correct?
Yes.
So that means that he's looking at the org name, the certificate.
Yes.
Because that's essentially another vBond. And then step 5, he's doing the same thing, is that right?
Step 5, I think he's getting the vBond information, but then in step 6, he's getting verified with the vBond, right?
Right.
So as step 5, the ZTP is just pointing what your right vBond is. So once he has given the vEd, the right vBond, he'll go and connect to that vBond, and all the authentication happens again, like the chassis and the serial number, certificates. Everything.
So I think the difference is in step 6, you're actually looking at the Symantec certificate or the customer-specific certificate, or like the CSR that was generated for a cloud vEd, right?
Yeah. Correct. All right. So we have PnP, which is a very similar service hosted by Cisco, which is very similar to ZTP. So all the
this
steps,
is relevant with the ISRs and
all the new devices that are coming in, all the ISRs, ASRs, and TSN platforms. Yeah. Mm-hmm. So all of these would use the Cisco version of the ZTP, so which is the PnP, plug and play. So all of the steps remains the same. Instead, you point to the Cisco ZTP server. And one other thing that has changed is we predefined some interfaces per platform, right? So like Gigi 00 for 1K. So here the platforms differs, and there are huge range of platforms. We don't want to do that and ask the customers to hard code this interface. So we actually loop through all interfaces until we get the first DHCP client configured on the interface and connect to the ZTP server. So that is the only difference.
So as long as the interface is connected and it detects that there's carrier on that link, it brings up DHCP client, no matter what port it's on.
Yes.
So
correct.
you don't have to know the platform and what port. Got it.
That is one of the improvements we did as part of this. Apart from that, it's all seamless, same. The way it joins the overlay, it is all the same.
So the only real difference is the DHCP client and the devicehelper.cisco.com versus ZTP.viptela.com.
Yes, correct. Some of the important notes while this process is happening. So we always want to have the device configuration template which is present on the vManage. Otherwise, when the device goes to the vManage, it will not find the right template and an image to come up with. So we definitely want that. And as a part of Viptela devices, we are predefining some of the interfaces, right, for the particular platforms. Care should be taken so that we'll not modify or delete any of the configuration that gets shipped predefined on the box before it comes to the overlay.